Recording. This is day 4. We're going to do inverse, sine, cosine, and tangent today. Before we do that, let's go through the warm-up. All right, so I'm going to ask you guys, what do you think I should model this with? I think we already talked about it, but since I'm recording, cosecant. Right? I would choose cosecant because I want to shift it if I do that, right? It's got that origin symmetry. So I'm going to do a cosecant. Whoops. Still records mistakes. What's the deal here? Oh. Okay, so it doesn't like my portrait sharer. Is that any better?
Great.
Let's try one more thing. All right, well, I can do it. We'll do it this way. All right, so we're going to do a cosecant. What's the period of that thing? Huh? Pi. All right, so that's different, right? Because the normal period is 2 pi, right? So my b would be 2. Yeah, it's 2 pi over the mean period, which is pi, so it's going to be 2. And we decided a cosecant. Now, we talked about it earlier about it being flipped because it's starting out negative here rather than positive. So one way to look at it is a reflection. Right, normally goes up first. So I'll put a negative there. All right, is it stretched? Depends on. Oh, I gotta find the midline. Where's the midline? So that midline's halfway between. It looks like -3 and 1. So it's halfway. Huh? I gotta close the door. Just so you know, we're recording the lesson for Monday. Okay. All right. What's halfway between -3 and 1? -1. So the midline's at -1. So I know it's down 1. All right, does it have a stretch on it? Yep, right, how much? What's the distance from the midline to the, whatever the vertice?
2.
2, so it's got a stretch on it of 2. We put that there, right? No shifts? All right, and then it's shifted how many up or down?
Down 1.
Down 1. So it's cosecant 2x parentheses -1. And that's your graph, right? You can always check these with a calculator. I would suggest you do when you first start them, right? Don't do them with a calculator, but check them. All right, we good? All right, so today we're going to learn the graphs of inverse sine, inverse cosine, and inverse tangent. Do you remember how to find an inverse going back to last semester? How to find inverse?
Plug in y for x.
Huh? For 2 things.
Plug in y for x. Plug in y for x.
Plug in y for x. Yeah, okay, and you said switch y and x, right? You're switching y and x, right? That's how we did it. So to graph an inverse sine, I don't memorize these graphs. I switch y and x, all right? And then it's going to be an inverse sine. On your calculator, if you guys have a calculator handy, I want you to understand that these graphs are, if you look at sine, cosine, and tangent right here, you see the guys in blue with the -1s? Those are your inverse sine, inverse cosine, inverse tangent. Okay. So what is an inverse sine? So if you take the sine of 30 degrees, the sine of 30 is what? What's the sine of 30? 1/2. The inverse is what angle that has that sign. So if I say what's the inverse sine of 1/2, you would tell me what angle has the sine of 1/2. Okay, but the sine of 30 is 1/2, right? So if I want the inverse sine of 1/2, I'm saying what angle has the sine of 1/2? What angle has the sine of 1/2?
30.
30. Okay. Now there's another one over in the second quadrant. We're going to talk today about why we don't. But inverse sine, they can't give you both on a calculator. All right. So we'll talk about that. All right. So I'm going to graph sine. Is it okay? I'm not going to use a table because you guys probably know this pretty well. All right. What's the sine of 0? Where does it start? 0. And that would be my pattern, right? Sine of pi over 2 is 1. Sine of pi is 0. -1. I'm just going to draw the pattern. Okay. So there's my sine graph. What's the domain of sine? All reals in the range,
-1 to 1.
-1 to 1. Actually, I'm going to put a few points on there. So the sine of negative pi is 0, because we're going to switch it to minus, so I figure I should put 0 there. What's the sine of negative 5 pi over 6? So first of all, what's the sine of pi over 6? Over 5 over 6. Put your finger down if you need to. What's the sine of 5 over 6?
1
1/2, right? 1/2, right? 3 fingers on top, 1 finger on the bottom, right? It's 1/2. Now, negative 5 pi over 6, negative means to go this way, right? So what's the sign down there? I think I heard it. Negative 1/2, right? All right, so the sign is negative 1/2. The sign of negative pi over 2, I'm just getting that off my graph, is -1. Negative pi over 6, that's going to be your negative 1/2 again if I draw the graph right. Sine of 0 is sine of pi over 6. Now we're up here positive 1/2. Sine of pi over 2, 1. 5 pi over 6 is going to be 1/2. 5. All right. So I did that for a reason. We're in graph the inverse sine. All right. So first of all, to have an inverse, remember a function had to be 1 to 1. How do you know if a function's 1 to 1? Passes which tests? Both vertical and horizontal. Okay. So this graph, the way it's written, does it pass both tests? Nope. All right. So what they do is they have to change it somehow. They're going to limit the domain to make it 1 to 1. All right. And this was arbitrary on their part, but they said, well, you know, I can't go from 0 to pi to I'm going to have to go from valley to peak, and then I have to stop, because when it starts turning around, it's not 1 to 1 anymore. So we're going to limit the domain to go from negative pi over 2 pi over 2. Did you see that piece is 1 to 1? Okay. So when you do an inverse sine, either on a calculator or by hand, you're only getting answers between negative pi over 2 and pi over 2. That's it. Okay? Because they have to make it 1 to 1. All right, so is it 1 to 1? No. So in order for it to have its inverse, it's necessary to limit the domain. So my restricted domain went from negative pi over 2 to pi over 2. And that way it's 1 to 1. Okay, so I didn't highlight, but it's just this little piece of the graph. No, I don't have a big pen. It's this thing I bracketed, right? Okay, so I just went from negative pi over 2 to pi over 2 to make it 1 to 1. So that's the only part that's going to be in my inverse sine graph. Okay, so the inverse sine is not periodic. Okay, because it's got a piece to it. That's it. All right. Everybody got this? Can I flip the page? Huh? Okay. All right, so what I'm going to do now is just flip y and x. I'm just going to so my x's went, I'm going to go from negative pi over 2 to pi over 2. I'm just switching y and x to the table. So my x is, the sine of negative pi over 2 is, oh, not negative 1/2. What is it? What's the sine of negative pi over 2?
0.
Nah.
It's 1.
Negative 1. There we go. It's negative 1. The sine of negative pi over 6.
Oh, I thought we were flipping.
We are. Notice I'm putting the y's in the next column, right? I don't have the angles as x anymore. I have the y's. I'm just doing it backwards. All right, the sine of 0, the sine of pi over 6, and the sine of pi over 2. 1. All right. So I'm going to graph these points. So this graph is going to have a different scale. My x is going to go from negative 1 to 1, and my y is going to go from negative pi over 2 to pi over 2. So the angles go on the y-axis now, because you're doing an inverse sine. All right, so I'm going to make this negative 1, just to give yourself some space. 1, 2, 3, 4. I'll make this 1. So these are each worth a quarter. All right, on the y-axis, let's see, what are we going to do? I go from negative pi over 2. Yeah, that's right, yeah. This is negative pi over 2, so this would be negative pi over 4. I'm gonna plot these points. So when x is negative 1, y is negative pi over 2. So that's here. Negative 1/2 is negative pi over 6. So pi over 6 is a little bit more than half of pi over 4. Because 1/8 would be half of that. Okay. A little bit more. All right, so this is 1/2. So pi over 6 would be probably about right there. Is that about right? Yeah. Okay, and 0 is 0. Sorry. Okay. Let's see. Yeah, 1/2. Pi over 6 is 1/2. So pi over 6, this is, no, 1/2 is pi over 6. So this is 1/2. Again, pi over 6 is not quite as high as pi over 4, so probably there. And pi over 2 is 1. Alright. Alright, so I'm going to connect my dots and see what I have. Alright. Now, ideally, I would like some more dots, but I'm just going to tell you this is what it's going to look like. That's not my best graph, is it? Alright. So if you turn that paper sideways, you see it looks like a sideways sign. It means flip, but it's a sideways sign. That's what I should see. Okay.
Yeah.
Huh? Sorry? I didn't do it very well. All of it. Huh? It looks like a cosine. Well, no, because here's 0. Signs start at 0, right? It kind of looks like a negative sign if I turn it this way. If I turn it counterclockwise. Okay. So, but it's a sine turn on the side. Okay, it's a sine lift. All right, so the inverse, the way that you write the inverse is you write it F inverse. Remember that -1 needs inverse, so for this graph we call it the inverse sine of x. All right, so you have a button on your calculator called inverse sine, and you can verify that graph just by plugging that button. So if I go to y equals, oh, they did a really nice picture here. I hate to destroy it. All right, and the inverse sine is right above sine. It's blue. The second inverse sine of x. And I'm going to hit, well, it's fine. I'm just going to graph it. I don't know if you guys can see this. Well, the little blue piece, right, looks like what I graphed. Right. All right. What's the domain of this graph? Where does x go from? Domain's x. Watch, be careful. I'm going to switch, right? -1 and 1. All right, and what's the range? Negative pi over 2 to pi over 2. All right, so one of the things you have to understand about your calculator is there's multiple. If I ask you what angle has a sine of 1/2, you told me pi over 6, but also 5 pi over 6 does too, right? But your calculator's not going to find that. It's only going to give you one between negative pi over 2 and pi over 2. So if you need to find the other one, you have to be smart enough to find the other one, all right? Because it's not going to find both, which we'll talk about in a few days. So that's the inverse sine. I don't memorize this graph. I just do a few points. I remember x and y are backwards, right? So I go, okay, well, I put the angles on the y-axis and this on the x-axis and just plot them backwards. Okay. Don't really memorize it. All right, so we're going to graph inverse cosine. So what I'm going to do is start off with a graph of cosine. Where does cosine start? At 1, right? And then we're going to do our pattern. Okay, there's cosine. What's the domain of this graph? What's the domain? All reals. And the range? -1 to 1. All right, same question. Is it 1 to 1? Nope, right? So guess what they're going to do? They're going to restrict the domain again, right? So if they try to go do like we did with sine, negative pi over 2 to pi over 2, you see that that's not going to work? That piece is not 1 to 1. So what they do is they say, all right, well, where's the peak? I have to go from mountain to valley, so I might as well start at 0 and go to pi. So So that's how they restrict the domain, so it doesn't turn around to make it one-to-one. Okay? All right, so it's not one-to-one. The restricted domain is different, right? It's gonna be from 0 to pi now to make it one-to-one. Okay? And we're gonna do the same thing we did before. Okay, so these are not periodic graphs, they're just a piece of an inverse piece of a sine or cosine. All right, we good? And no, not yet. Okay, everybody good? All right, so so the way they write the inverse cosine, guess what? It's cosine -1 of x, right? So this means inverse cosine. All right, so I put the x's where the y's are, I'm gonna fill in the chart. So remember, I'm only going from 0 to pi because I'm restricting the domain, right? All right, what's cosine of 0 degrees? 1. What's cosine of pi over 3? I picked an easy one on purpose. 1/2. Cosine of pi over 2? 0. Cosine of 2 pi over 3? -1/2. Cosine of pi? -1. So these are now my x's and the angles are my y's. I'm going to do the same thing I just did. All right, I'm going to let x go from -1 to 1. And y goes from 0 to pi, so that's kind of interesting because we're not going any negatives, right? The angles just go from 0 to pi. So let's get some stuff in there. If this is pi, this is pi over 2. We'll see how that fits. All right, so I'm going to start plotting these points. All right, so 1, 0, 1, 0 is right here. 1/2 pi over 3. All right, pi over 3 is, this is 3/6, so it's like 2/6, so it's like 2/3 of the way up there. Roughly, it's 2/3 of the way, it's put their way to pi, so we'll call it about right here. Is about 1/2. Pi over 2, something's wrong. Oh no, I just can't. I'm thinking x is on, okay, pi, 0 is pi over 2, right? I have to think backwards. All right, so 0 is pi over 2, that's right here. Okay. -1/2 is 2 pi over 3, so that's like 2/3 of the way to pi. So that's, I mean, I'm just estimating, right? About there, I don't really know. All right, and -1 is pi. All right, so if I connect the dots, you get something that looks like that. You turn that paper 90 degrees clockwise, you see you have yourself a cosine wave. Yeah, okay. So I don't memorize these, I just know, okay, I switched a couple points and I got it, right? All right, I don't really see. What's the domain of the new graph now? -1 to 1, and the range?
0 to pi.
0 to pi. Okay, so when you take inverse cosine on a calculator, it's only going to give you an answer between 0 and 180, so it's not going to give you anything down the third or fourth quadrants, which you have to be aware of. Okay? All right. All right, the last graph we have is inverse tangent, I'm quite sure. Blank screen. What happened? Oh, let's talk about, I'm sorry, I already did this, right? But I want to talk about these things down here. So the cosine of pi over 2 is what? Let's get this in our brain. What's cosine of pi over 2? 0. So guess what? If the inverse cosine of x is pi over 2, then x is what? 0, right? All right, because the inverse cosine of 0 is pi over 2. We're working the opposite way, okay? So the inverse cosine of 0 is 0. Now these will only have one answer with the inverse cosines, right? It's going to be between 0 and pi. I don't care about the other one necessarily. Okay, 3 pi over 2, not in my domain.
There was another one.
But it's, yeah, on the inverse cosines. Oh, there's another one? On the sine, all right, I'm sorry, it's the same thing. It's the same thing. I just want you to understand it's only going to return a value in its restricted range.
It doesn't change, even though it's the cosine of, even though it's the inverse, it doesn't change, it's still 0.
The inverse cosine of 0 is only pi over 2. It's not 3 pi over 2 because that's outside of my 0 pi. Okay, so
Sine of pi over 2 is negative 1.
no, cosine of 3 pi over 2 is 0.
Or the sine of pi over 2.
Yeah.
What's the sine of pi over 2?
1.
Oh.
So, yeah. Okay.
Oh, yeah, I was looking at
Okay. All right. We're gonna deal more with this in that particular issue in a few days. All right. Tangent. Okay. Let's do a few things. What's the tangent of 0? 0. Tangent of pi over 4.
1.
1. Tangent of pi over 2. Undefined. This is where your vertical asymptote is. I want to go back and look at that. 3 pi over 4.
1.
I'm going to stop there. I don't like this. All right, we're going to graph it. Do we have it? You guys have the graph in your notes?
Yes.
Okay, we're just going to graph it. All right. So, what does tangent look like? Where's asymptotes? Pi over 2, and 3 pi. Well, we're gonna keep this PG. All right. It's perfectly arbitrary. They could have chosen to do between pi and 3 pi over 2. They didn't. They chose to do from negative pi over 2 to pi over 2. But I'm going to graph a few periods of it. I want you to understand. Okay, not so good. All right, is this graph 1 to 1 right now? No, so they have to restrict the domain again. How do you think they're going to restrict the domain? Yeah, they're going to take the first two asymptotes there. Okay, to make it 1 to 1. So it's the same thing. So the inverse tangent only goes from negative pi over 2 to pi over 2. That's it. All right, and we can't return multiple answers. Justin, can you solve that way, please?
Yeah.
All right, so what I'm going to do is graph the inverse tangent. So it's not periodic. I'm just going to take that one period of it, all right? So here's the deal. You have asymptotes on the original graph at x equals pi over 2 and x equals negative pi over 2. So what do you think is going to happen to those vertical asymptotes when you switch y and x?
Return the opposite.
Yeah, they're going to turn into horizontal, right? Because x is going to become y. So the new asymptotes are, oh, wait a minute. Why do I have this graph again? Is this the same graph?
Yeah, it has
Okay.
that twice.
All right. There we go. So the new asymptotes are going to be at y equals pi over 2 and y equals negative pi over 2, right? Because those are my asymptotes. So the tangent of these guys is undefined. The tangent of negative pi over 4, negative 1, 0, 1. We just did those, right? Okay. And the way we write it is negative 1. So I'm going to graph this graph. Where it's undefined, I'm going to put those horizontal asymptotes, right? What do you want to call, how do we want, well, I guess, how big do you want your scale to do? I'm not going to do it that big. We'll call this negative pi over 2 here, and pi over 2 here, right? The angles go on the y-axis, and the numbers go on the x. We'll go from negative 1 to 1. All right. So those vertical asymptotes become horizontal. So I'm going to put two horizontal asymptotes, one at pi over 2 and one at negative pi over 2. All right, I'm going to plot a few points. Negative pi over 4 is negative 1, so negative pi over 4 would be, no, I'm sorry, I got to do this backwards. Negative 1 is negative pi over 4, so negative 1, what? When x is negative 1, y is negative pi over 4, right? Is that right? Yeah, it's going to head to the asymptote. I should have maybe picked a smaller scale, but I'll be all right. All right, 0, 0 is there, and pi over 4, 1 is pi over 4, so we're going to be up here. All right. So what I want you to understand is this is the tangent turned on its side. So what you're going to see, it's going to go from the point and head down to the asymptotes. All right, so if you turn that 90 degrees sideways, you see you have a kind of a tangent looking thing. It looks more like a cotangent, but still like a tangent. Okay? Alright, yeah, alright, what's the domain of that graph, the new graph?
Real.
All reals, right? And what's the range?
5 to
Negative 5 or 2 to,
5 to
and we're gonna use round brackets because we got horizontal asymptotes, right? Okay? So that's it. I don't memorize these graphs, I just do a few points and oh yeah, it looks like that. Because there's no point. It's just the opposite of sine, cosine, tangent. Alright, what's the tangent of pi over 4? Let's make sure we get this. So if the inverse tangent of x is pi over 4, then x is what? 1. So the inverse tangent of 1 is, and again, it's only going to give you the one between negative pi over 2 and pi over 2. Okay? So these are your inverse sine, cosine, tangent, all right? The expectation here is being able to recognize these graphs. Okay? That's it. All right. Is that it for today?
yeah.
Oh, let's, you don't have those, or you do?
No.
You don't? Okay. I'm gonna stop there. I don't want to do this right now. All right. All right. So the only homework for this unit, you have these though, don't you?
Yeah.
Yeah. You need to do these. All right. So I want you to think backwards. Inverse sine 1/2. What angle has a sine of 1/2?
Pi over 6.
Pi over 6. So there would be pi over 6. It would only be pi over 6, just 5 pi over 6. Remember, inverse sine only goes from negative pi over 2 to pi over 2. So 5 pi over 6 is not in that range, right? All right, so inverse cosine only goes from 0 to pi. So what angle has a cosine of negative root 2 over 2 in this range? Huh? What angle is this cosine of 2 over 2? Negative. Use your finger.
45.
45, but I need it in the right quadrant, right? It's negative, so it's going to be
Yeah.
quadrant 2. So
So
what
it's
angle
going to
is that?
be 135.
135. And in radians, that would be 3 pi over 4. I don't care about the other angle that's in the third quadrant because that's my range is going from 0 to pi. We're talking inverse trig here. All right, so inverse secant of 0. So what I'm asking you is what angle has a secant that is equal to 0? So if the secant is 0, what does that tell you about the cosine? 1 over 0, which is undefined. Is there any cosine angle that's undefined? So this has no answer. I don't know why. All right, inverse tangent of negative 1. Okay, so remember, inverse tangent goes from negative pi over 2 to pi over 2. That's it. So what angle in that range has a tangent of negative 1? Pi over 2. Where is sine and cosine equal?
45.
45, right? So now, here's the, it's pi over 4, but it needs to be negative. I cannot tell you like 3 pi over 4 or 7 pi over 4. It has to be between these values. So the way I do that is say negative pi over 4. Are you with me, Hunter?
Mm-hmm.
All right, so it has to be between the fourth quadrant and the first quadrant, right? So I would say negative pi over 4. So in the same reasoning, what angle has a sine of negative 1/2? So it's got to be between here and here. So get 1/2 first. What angle has a sine of 1/2? 5 over 6. And you can just take that negative out of there if you want to think about it that way. Okay? All right, so I just want to make sure we did a few of those. All right, now we're good. All right, so you got homework 4. Happy day. Say hi to 5th and 6th period. They're going to listen to this so much.
Mm-hmm.
All right, thanks, guys. Let me get rid of this. How do I turn off the recording?
Nice.